One night on July 17, 1996, dozens of people along the coast of Long Island saw something rise from the ocean toward a distant aircraft. Some described it as a streak of light, others saw what looked like a flare or firework ascending into the darkness. Seconds later, the sky erupts into a massive fireball that would become one of the most controversial aviation disasters in American history. TWA Flight 800, a Boeing 747, had departed JFK Airport at 8:19 p.m. bound for Paris, with a planned journey to Rome. 230 people were aboard. Passengers and crew settled in for what should have been a routine transatlantic flight. But approximately 12 minutes after takeoff near East Mauritius, New York, something catastrophic occurred at 13,800 feet. The question that emerged in those first horrifying hours has never fully left the public consciousness. Was TWA Flight 800 shot down? The streak of light witnesses reported seeing became the cornerstone of a theory that refuses to die. Does a missile, perhaps from a naval exercise gone wrong or something more sinister, brought down the aircraft? At 8:19 p.m. Eastern Daylight Time, TWA Flight 800 pushed back from the gate and began its journey towards Paris Charles de Gaulle Airport. The Boeing 747, one of the workhorses of international aviation, carried its passengers and crew through a normal taxi and takeoff sequence. Weather conditions were good, visibility was clear. In the cockpit, Captain, Pilot in Command Ralph Kevorkian and Captain Steven Schneider, right seat, worked through their routine procedures as the aircraft climbed steadily over the Atlantic. The systems appeared normal, though Captain Kevorkian did mention something odd to his colleague. He noted that the number 4 fuel flow indicator was acting crazy, an observation that would later prove significant to investigators, though at the time it seemed just like another minor instrumentation quirk in an aging aircraft. At 20:31 and 12 seconds, precisely 12 minutes and 33 seconds after takeoff, what the NTSB would later term the initial event began. The flight data recorder and cockpit voice recorder both stopped recording, their electrical connections severed. According to NTSB modeling, between 20:31:15 and 20:31:19, just 3 to 7 seconds after that initial event, the forward section of the aircraft, including the cockpit and first-class cabin, separated from the main fuselage. But the destruction wasn't instantaneous. At 20:31:46, 34 seconds after the initial event, the right wing tip failed. 4 seconds later, at 20:31:50, the left wing center section separated. These weren't simultaneous failures, but a cascade, each structural failure following from the one before. The aircraft literally coming apart in stages as it fell from the sky. This precise timeline, reconstructed from radar data, wreckage analysis, and exhaustive simulation, would become crucial to understanding not just what happened, but what didn't happen to TWA Flight 800. When TWA Flight 800 fell into the Atlantic Ocean, it didn't fall as one piece. The wreckage scattered across the seafloor in 3 distinct debris fields that investigators would color-code as red, yellow, and green zones. These weren't random designations, they mapped the sequential breakup of the aircraft, with each field telling a story about what separated when. The recovery operation that followed was one of the most extensive in aviation history. The US Navy, working with the NTSB and multiple other agencies, ultimately recovered more than 95% of the aircraft by weight. Navy divers spent months in dangerous conditions methodically searching an ocean floor area larger than Manhattan. This wasn't about finding pieces, it was about finding answers, and every fragment could potentially explain whether this was an accident or an attack. The recovered wreckage was transported to a hangar in Calverton, New York, where investigators performed an extraordinary feat of reverse engineering. They reconstructed a 94-foot section of the Boeing 747, painstakingly placing each recovered piece into a steel framework that recreated the shape of the aircraft. This reconstruction would serve as a 3-dimensional puzzle, revealing blast patterns, breakpoints, and the sequence of structural failures. For 2 decades, this ghostly skeleton of TWA Flight 800 served as a teaching tool at the NTSB Training Center in Ashburn, helping investigators learn to read the language of aviation disasters. It wasn't decommissioned until 2021, having taught its lessons to generations of safety professionals. But long before then, it had already revealed its most important secret about what happened that night. The missile theory didn't emerge from nowhere. There were those witnesses. The FBI and other agencies collected statements from everyone they could find who had been watching the sky that night. The CIA would eventually analyze 244 of these eyewitness accounts in detail, looking for patterns in what people saw and, crucially, what they thought they saw. The descriptions were remarkably consistent in one key aspect. Many witnesses reported seeing a streak of light rising from the surface towards the aircraft. Some described it as looking like a flare, others compared it to fireworks. Several insisted it resembled a missile launch they'd seen in movies or military footage. For people standing on beaches, sitting in boats, or glancing up from their evening activities, something appeared to rise from the ocean and intercept TWA Flight 800. This wasn't mass hysteria or conspiracy thinking. These were regular people describing something real that they observed. The question wasn't whether they saw something. They absolutely did. The question was whether what they saw was actually what they thought they saw. Distance, darkness, and limitations of human perception at night can transform one phenomenon into something that looks entirely different. The CIA would eventually produce an animation titled "What Did the Witnesses See?" that attempted to reconcile these eyewitness accounts with the physical evidence. The NTSB conducted their own extensive witness studies, categorizing observations by location, timing, and description. What emerged from these analyses would challenge the missile theory in unexpected ways. But to understand how, we first need to examine what the witnesses were actually looking at that night. The answer involves physics, perception, and a peculiar characteristic of how damaged aircraft behave in flight. One of the most counterintuitive aspects of TWA Flight 800's destruction was what happened immediately after the nose separated from the aircraft. According to NTSB simulations based on radar data and aerodynamic modeling, the remaining fuselage didn't simply fall. Instead, it did something that would profoundly affect what witnesses saw. It climbed. When the forward section tore away at 13,800 feet, the center of gravity shifted dramatically rearward. The aircraft's wings were still generating lift and the engines were still producing thrust. With the way the nose section suddenly gone, the crippled fuselage pitched upward sharply. The simulations indicate this decapitated aircraft climbed from its initial altitude to somewhere between 15,500 and 16,700 feet, ascending nearly 2,000 feet after the initial catastrophic failure. This zoom climb lasted perhaps 20 to 30 seconds before the remaining structure failed completely. During this time, fuel continued to burn from the ruptured tanks, creating a rising, flaming object in the night sky. From the beaches of Long Island, observers 8 to 12 miles away would have seen what appeared to be a streak of light ascending from the ocean surface, when in reality, what they were watching was a crippled aircraft climbing while on fire, with the dark ocean providing no visual reference for depth or distance. The radar data confirmed this trajectory, showing the primary returns that tracked this climb before the aircraft finally broke apart completely. Multiple radar sites captured these returns, and they align precisely with the physics of how a catastrophically damaged 747 would behave in those specific circumstances. Given the geopolitical climate of 1996 and recent terrorist attacks against aviation, the possibility of a bomb or missile strike was immediately investigated. The evidence seemed compelling at first. Laboratory analysis detected trace residue of explosives, specifically RDX, PETN, and nitroglycerin, on a few pieces of wreckage. For investigators and the public alike, this discovery initially seemed to confirm the worst fears. But forensic analysis requires more than just chemical traces. If a bomb or missile had destroyed TWA Flight 800, the wreckage would show specific, unmistakable signatures. Investigators looked at the telltale signs: petling of metal where blast pressure tears through structures, and embedded shrapnel that missiles and bombs produce, the distinctive hot gas washing that explosives leave on nearby surfaces, and the microscopic cratering that high-velocity fragments create. None of these signatures were present. The explosive residues were found on only a few items without any of the accompanying physical damage that actual explosive devices invariably cause. The NTSB methodically examined contamination pathways from military dog training exercises previously conducted on the aircraft to the potential for residue transfer during recovery operations. Their conclusion was definitive. The breakup was not initiated by a bomb or missile. To address the missile theory specifically, the NTSB conducted visibility tests at Elgin Air Force Base on April 28, 2000. They wanted to know what witnesses would actually see if a shoulder-fired missile had been launched at an aircraft. The test revealed a specific signature. Observers would see a bright ascending light for approximately 8 seconds as the missile motor burned, followed by a dark coast phase, then potentially a separate, slower-moving flame at the point of impact. This 3-phase visual pattern, bright ascent, dark coast, impact, was not what witnesses reported seeing that night. They reported a single rising streak, which aligned perfectly with the zoom climb of the burning aircraft. To understand how TWA Flight 800 could explode without any external attack, we need to examine a specific vulnerability in the Boeing 747's design, one shared by many aircraft of that era. The center wing tank, or CWT, sits in the belly of the aircraft between the wings. It's a large aluminum box that, on this particular flight, contained only about 50 gallons of fuel, just enough to create a massive amount of vapor above the liquid. Directly beneath this tank sits the aircraft's air conditioning packs. These are essentially the heating and cooling units that keep the cabin comfortable. On July 17, 1996, TWA Flight 800 sat on the tarmac at JFK for approximately 2 3/4 of an hour, with these air conditioning packs running continuously in the summer heat. The NTSB's investigation revealed that during this time, temperatures in the equipment bay reached between 148 and 228 degrees Fahrenheit. The air conditioning components themselves reached temperatures between 250 and 350 degrees. This heat had nowhere to go but up into the aluminium structure of the center wing tank above. The fuel inside absorbed this heat, and more critically, the fuel vapors inside became warm enough to fall within the explosive range. What had been a relatively safe fuel tank at cooler temperatures became essentially a bomb waiting for a spark. This wasn't negligence or poor maintenance. This was a design characteristic common of many transport aircraft of that generation. The proximity of heat-generating equipment to fuel tanks was an accepted engineering trade-off, one that had worked safely for millions of flight hours. But under specific conditions of that evening, a lengthy ground delay, hot weather, and minimal fuel in the center tank, the design created exactly the wrong conditions. The NTSB's probable cause finding was specific and careful in its language. They determined that TWA Flight 800 was destroyed by a fuel-air explosion in the center wing tank. The most likely ignition source, according to their extensive investigation, was excess voltage from a short circuit entering the tank through the Fuel Quantity Indication System wiring, the FQIS. The FQIS is the system that tells pilots how much fuel is in each tank. It uses electrical probes inside the fuel tank to measure fuel quantity. Now, under normal conditions, these probes operate at very low voltage, insufficient to create a spark. But the investigation revealed that the FQIS wiring ran alongside high voltage wires carrying 115 and even 350 volts. In an aircraft that was already 25 years old with thousands of hours of vibration, temperature cycles, and mechanical stress on its wiring, the insulation had degraded. The NTSB found evidence of arcing in other areas of the aircraft's wiring, demonstrating that electrical failures were already occurring. Remembering Captain Kevorkian's comment about the crazy number 4 fuel flow indicator just minutes before the explosion? That seemingly minor anomaly suggested that electrical irregularities were manifesting in the aircraft systems. While investigators couldn't determine the exact location where the fatal spark occurred, that evidence was destroyed in the explosion, they could trace the pathway by which dangerous voltage could have entered the tank. While the NTSB investigated the technical cause of the crash, the FBI ran a parallel criminal investigation to determine whether TWA Flight 800 was brought down by an act of terrorism or warfare. This wasn't unusual when 230 people die in a suspicious aviation event. Law enforcement must examine every possibility of criminal activity. For 16 months, the FBI conducted one of the most extensive investigations in its history. Agents interviewed thousands of witnesses, analyzed radar data, tested explosive residue, and explored every credible lead suggesting criminal activity. They worked with the CIA, which provided technical analysis of witness testaments and created a now famous animation titled "What Did the Witnesses See?" This animation wasn't meant to investigate the crash itself. That was the NTSB's role. Instead, it aimed to explain how the physical events the NTSB had documented could account for what witnesses reported seeing. In November 1997, the FBI held a press conference to announce their conclusions. After examining all available evidence, they found no evidence of a criminal act, no missile, no bomb, no act of terrorism. The explosive residue traces had innocent explanations. The radar data showed no approaching missiles. The wreckage patterns were inconsistent with external attacks. The witness observations, when properly analyzed, aligned with the zoom climb of a crippled aircraft rather than a missile strike. This conclusion didn't satisfy everyone. Some families and investigators believed the FBI had closed the investigation prematurely or under pressure. But the criminal investigation's end allowed the NTSB to complete its safety investigation without the constraint of preserving a potential crime scene. The two investigations, running on parallel tracks, had reached the same destination. TWA Flight 800 was not brought down by an external attack. 17 years after TWA Flight 800 fell into the Atlantic, a group calling itself the TWA 800 Project petitioned the NTSB to reopen the investigation. The petitioners weren't conspiracy theorists from the internet. They included former investigators who had worked on the original case, aviation professionals, and retired military personnel. Their core claim was direct. TWA Flight 800 had been destroyed by a high-velocity explosion external to the aircraft, most likely a missile. The 2013 petition was accompanied by a documentary film that presented what the group considered new evidence. They argued that the NTSB had ignored or misinterpreted crucial witness testimony. The radar data showed objects approaching the aircraft, and that the pattern of damage to the aircraft was consistent with a high-velocity external explosion rather than an internal fuel tank blast. They requested that the NTSB reconsider its findings in light of what they presented as overlooked or suppressed evidence. The NTSB took the petition seriously enough to conduct a thorough review. In 2014, after examining all of the material submitted by the TWA 800 project, the Safety Board issued its response. The petition, they concluded, did not provide any new evidence that would undercut the original findings. The board found that the petitioners had misrepresented some evidence, taken other evidence out of context, and failed to provide any physical proof that contradicted the center wing tank explosion causation. The tragedy of TWA Flight 800 didn't end with determining the cause. It sparked fundamental changes in aviation safety that protect passengers today. Beginning in December 1996, even before the investigation concluded, the NTSB issued urgent recommendations calling for methods to reduce fuel tank flammability or prevent ignition sources. The message was clear: eliminating sparks wasn't enough if the tanks remained explosive. It took 12 years, but in July 2008, the FAA published a final rule that transformed fuel tank safety. The new regulations, codified under 14 CFR 25.981 and Part 26 Subpart D, required what the industry calls fuel tank flammability reduction and ignition mitigation means. Rather than mandating a single technology, these performance-based requirements allow manufacturers to choose their methods, whether nitrogen systems that replace explosive oxygen with inert gas, or other approaches that achieve the same safety goals. Today, when you board a commercial aircraft, hidden systems work continuously to ensure that fuel tanks remain outside the explosive range that destroyed TWA Flight 800. 230 people died that night off Long Island. From their loss came regulations that have prevented similar disasters for nearly 2 decades. Every modern airliner carries the lessons of TWA Flight 800 in its design. A permanent memorial written in engineering standards and safety systems that passengers never see but benefit from every single flight. Those who maintain TWA Flight 800 was shot down point to several contested elements that remain unresolved in their view. Unidentified vessels were reported in the area that night. The crash occurred near military warning areas where naval exercises take place. Some radar data showed unexplained returns that critics argue could represent missiles. The explosive residue found on the wreckage remains suspicious to those who question the innocent explanations offered. But the physical record simply tells a different story, the one that you've heard today. The alternative theory requires accepting that hundreds of investigators from multiple different agencies either missed or deliberately concealed evidence of an attack. It requires explaining why the physical wreckage lacks the unmistakable signatures that missiles and bombs always leave. It requires dismissing the aerodynamic explanation for the zoom climb that matches witness observations. While questions remain for some, the weight of evidence points consistently in one direction. So, was TWA 800 shot down? According to evidence and official investigations, no, it wasn't. Thank you for watching.